Hey there, everybody. Thanks for tuning in today. Today we're going to look at taking a derivative of inverse functions or calculating a derivative of inverse functions at specific points. This continues our look of derivatives of composite, implicit, and inverse functions here in our third unit. Let's start here with a little talk about inverse functions and what they are. So we have if f of x and g of x are inverses, the slopes at the mirrored points are reciprocal. So let's take a look at this graph here. We're going to call this graph f of x. Okay? So it says what point is on the graph of x to the 1/3 at 8? So here's our point at 8. That point would be 8, 2. The second question says, what's the slope of the graph at that point? Remember, slope in calculus is the derivative, right? So we are going to take the derivative of f and rewrite it a little bit here. So 1/3 to the 2/3. And then to find the slope at 8, we're simply going to plug in 8 for our x. Okay, 8 to the 2/3. So you can think of that as the third root of 8 squared. The third root of 8 being 2. 2 squared is 4. So this is 4. 4 times 3 is 12. So this is 1/12. So the slope of the line there would be 1/12. If we drew a tangent line at that point, the slope would be 1/12. All right, so now we're talking about inverses. C says, what point is on the graph of the inverse of x at 2? So if you remember from your inverse days in Algebra 2 and pre-calc, for an inverse, all we're going to do is we're going to switch x and y. So the point would be at 2, 8. So 2, 8 would be up here. And we can get more of these points if we wanted to. Really, the graph would look something like this. That's not a very good graph. Hold on, let's try this again. There we go. There's what the graph would look like of the inverse. So we'll call that f inverse of x. And you can see the point 8, 2 is on there. Okay? Going a little bit further into detail into what you did probably last year's math class or the year before that math class. This line right here is a line y equals x. That should be a mirror between the function and its inverse graph. Okay, but most importantly, now we're saying what is the slope to the tangent line at this point? And that brings us back to here. If functions are inverses, the slopes of the mirror points are reciprocals. So if the slope here was 1/12, we know that f inverse prime of 2 would be the reciprocal of 1/12, which is just 12. And you can see there, that is a pretty steep line there. So 12 looks like a correct answer. There's a couple ways to do this. This first method here, this only works if it's easy to actually find the inverse function of the original function. This is not going to happen most often in calculus. We're not going to make it that easy on you. Well, let's take a look at what would happen if it would. So the first step here would be to find the inverse function. So we do that by exchanging x and y and then solving for your new y. So we have the inverse of f is x to the 1/2 or root x. Okay, so now if I want to find the derivative that would just be 1/2 x to the negative 1/2 or 1/2 root x. And if I want the value of the derivative at 4, well, then I simply put 4 into that equation. That would be 1/2 times 2, or 1/4. Again, that's usually not something we see in calculus. It's usually a little bit more difficult than that. So let's take a look at example 2, or method 2 here. This method is used when finding the inverse of the function for solving for the y is either really difficult or strictly impossible. Okay. So first thing we're going to do here is we're going to interchange x and y just like we did in the last part. So x equals and now we're going to differentiate this implicitly. So dx is 1. And you can see here each part with a y in it. We're going to multiply by dy dx. And the derivative of a negative 1 is, of course, 0. Factoring out a dy dx, and then dividing, we get our derivative to be 1/3y squared minus 8y plus 7. Okay? So now what we want to do here is we want to figure out what y do we put at that. Because this, remember, this is the inverse, so this is the derivative of the inverse. Okay? But we don't have a y value. All we have is an x value here at 1. All right, so what we're going to do is we're going to set this equation equal to 1. And solve for y. And to make this a little bit easier on ourselves, if we add 1 over, we would get this equation. This is unnecessary, but it might make it a little bit simpler. So what we're going to do here is we're going to put this into y1 of our calculator and this into y2 of our calculator, and we can see when these intersect, and that's going to be our answer here. Okay, so our answer for this problem would be approximately 0.3494. Okay, and again, what you would do to do that is put this into your calculator as y1, put this into your calculator as y2. Now, a calculator doesn't know the difference between x's and y's, so really what we're doing is we're putting x's in, so your answer is going to be the x coordinate of what the calculator gives you as the intersection point, but really we know it's a y coordinate for this graph. Okay, so then what we're going to do, finally, is find our derivative at this point. Okay, so if we want to write that properly, it would be f inverse prime of 1 is approximately, and again, what we're going to do is we're going to take this y value and put this in here. And of course, you are allowed to use your calculator for that as well. And we should get approximately 0.219. A little bit more complicated. Now that method, we can kind of streamline that method here into a formula. The inverse derivative of x is equal to 1 over f prime of f inverse of x. Okay? What does that mean? Let's take a look at this problem here, and we'll try to talk through what might be an easier way of thinking about this here. Okay, again, this is just the reciprocal. We talked about it earlier, right? It's just the reciprocal of the original derivative at that value. Okay? So example 3 says, find the derivative of the inverse function of f of x at x equals pi using the formula above. All right. So taking the derivative of f will get us 1 plus cosine of x, right? Now, if we were to, let me use a different color here. So again, we're looking at x equals pi on the inverse function, not x equals pi on this function. So if x equals pi on the inverse function, remember what that means from the first slide here. If on the inverse function, the point is pi comma something, on the original function, the point would be something comma pi, right? So our y coordinate would be pi. If we put pi, excuse me, if we put pi into our y coordinate here, then we're gonna think about, all right, when would x plus sine x equal pi? Okay, another way of thinking about this here would be if we took the inverse of our original function, so f inverse of x. Actually, let's go back a step. Let's just go ahead and exchange x and y here first. Okay, now we can see our derivative there. And again, we talked about on the actual inverse, pi is your x coordinate, right? So we have pi equals y plus sine of pi. Well, sorry, y plus sine of y, okay? Thinking about how we would solve this equation, we probably want this to be 0. That's the only way we're going to get this to work. So that would be 0 at 0 and pi, or 2 pi and 3 pi, but really just 0 and pi is all we need. If we put 0 in, we would get 0 plus 0, so that's not going to work. But if we put pi in, we would get pi plus 0. So really, our y-coordinate is also going to be pi. So that's, again, that's on the inverse here, right? This is the inverse. But that means the original function is also pi comma pi. So these points are going to be mirrors of each other, okay? So what we need to do then is go back to our derivative, find our slope at pi. The cosine of pi would be -1, so it would be 1 plus -1. So the slope would be 0. And because what we learned in the first slide, the point on the inverse would have a mirrored, or the mirrored point, the inverse would have a reciprocal slope. So f inverse prime of also pi, because it's the same point, would be 1 over 0, which of course we know is undefined. More often than not, on AP problems, you're going to see things like this, a table of values, okay? So if we think about this, the question is not going to be written in 4 steps like this. The question probably just be this, okay? And it's kind of our job to figure this out, what it's asking. But this is the thought process you would go through. So what point is on the graph of f at 3? That would be the point 3, -1. What is the slope at that? So f prime of 3 would be 2. So then what point is on the graph of the inverse at -1? So that would just be -1, 3, because they're mirrored points. What would the slope be at that point? The reciprocal of this slope here, which would be 1 over 2. So here's another table problem. It says selected values of a strictly monotonic function g of x and its derivative g prime of x are shown on the table below. Okay? And part A says to find g inverse prime of 1. So here's how we can go about thinking of this. We can think of, all right, here's g of x, and here's g inverse of x. All right? I know g inverse of x, the point is 1 comma something that we're looking at here. So on g of x, it's going to be something comma 1. So let's go to the table and see where is our y value 1 for g of x. And that would be right here. So the point is negative 1, 1 on g, and 1, negative 1 on g inverse. So on our slope, so g prime of negative 1 is right here, negative 1/5. G inverse prime of 1 would be the reciprocal of that, which is negative 5. So that's more often the type of problem that you would probably encounter in this class. It really just involves a little bit of thinking to get through it. So for B, same thing here, looking for g inverse prime of negative 3. So we know, there's g of x here. We know on g inverse, the point is negative 3 comma something. So on g, it's something comma negative 3. That would be on x is 4. So that means the y coordinate over here is 4. So we want to know what is g prime of 4. G prime of 4 would be negative 2. So then g inverse prime of negative 3 would be the reciprocal of that, or negative 1/2. Okay, at this point, there's a couple practice problems on the next slide. I would suggest you pause the video here, try them, and come back when you're ready. All right, here's my work and answer for the first problem. You can see that G and F are inverses. We know that on G, the point is negative 2, 5. Therefore, the point in F is 5, negative 2. We know the slope at F prime of 5 is negative 1/2. So then the slope of G at negative 2 would be the reciprocal of that negative 2. Number 2, done pretty much the same way. You can see the work for that one there. The only difference is they don't give us a y value for g, so we got to find that, but that's okay. We can find that pretty easily. And they don't give us a derivative of g, so we can find that pretty easily as well. And we can put those numbers where they belong. What we're looking at here is the slope of g at 1 is 4, so the slope of that mirrored point would be the reciprocal of that, which is 1/4. All right, that'll do it for our look into the derivative of inverse functions. Thanks again for checking in today. We'll see you soon.